Good morning. Today we're going to continue on with polar equations and functions, and we are going to talk about how to convert between polar and rectangular forms of both points and equations. So this one will be a little bit longer than the last lesson. Um, Biggest thing you need to remember is when we talked about the unit circle, remember x is cosine, y is sine, and then r is actually a radius. So in the unit circle, r was always 1. So x, if you're setting up some trig to figure out the value of x is equal to r cosine of theta, y is equal to r sine of theta, and then x squared plus y squared equals r squared, which is the equation of a circle that you learned about in conic sections. And then remember, tangent is sine over cosine or y over x. We're going to use those to change these back and forth. So we are going to use those essentially formulas to convert points to rectangular form. So what you need to remember here is x is your cosine, right? So x is going to be r cosine of the angle, and y is going to be your sine, so r sine of the angle. So when I plug that in, to find my x, I'm going to do 2 times cosine of 3 pi over 2, and y is going to be 2 sine at 3 pi over 2. So you do need to know your unit circle. So pi over 2, pi, 3 pi over 2 is at the point 0, negative 1. So if I plug in 0 here, this gives me 0. If I plug in negative 1 here, I get negative 2. So the rectangular coordinates that correspond are 0, negative 2. We're going to do the same thing here. X is going to be negative 8 cosine of pi over 3. And y is going to be negative 8 sine of pi over 3. So if we think of pi over 3, this angle right here, we have 1/2 square root of 3 over 2. So we're going to plug those in. So I get negative 8 times 1/2 for my x, which gives me negative 4. And I get negative 8 times the square root of 3 over 2, which gives me negative 4 times the square root of 3. That's a 3 and a 2. Okay, that's all you're doing to change polar coordinates to rectangular coordinates. You need to remember r cosine and r sine. So x is cosine, y is sine. Okay, we're going to convert points from rectangular to polar. So we're kind of going backwards. We're going to start by plotting the point. We're going to find the radius and then use, I find theta using tangent equals pi over x to find your actual angle for the point. So let's go through those steps there. Okay, so find the polar coordinates of the point whose rectangular coordinates are negative 1 square root of 3. So I'm going to go ahead and plot that. Negative 1 square root of 3, we'll say, is right there. Okay, so I know it's in the second quadrant. I need to start by finding my radius. So my radius is going to be the square root of negative 1 squared plus square root of 3 squared. And we're going to simplify. So negative 1 squared is 1, square root of 3 squared is 3. So if I combine those, I get 4, and then the square root is 2. Okay, and it's positive. And then to find my angle measure, we're going to do tangent of theta equals sine over cosine, or y over x. So you need to think about when tangent is negative square root of 3. Okay, so on my unit circle here, tangent in the second quadrant, square root of 3 would be right here, which is going to be 2 pi over 3. Okay, so this goes back to knowing your unit circle really well. Should help you review your trig. It's a positive 2. 2 pi over 3. Okay, let's do another one. Find the polar coordinates of the point whose rectangular coordinates are negative 2, 0. So negative 2, 0 is right here. Your radius is going to be the square root of negative 2 squared plus 0 squared, which is really just 2. Okay, so negative 2 squared is 4, square root of 4 is 2. And then to find our angle measure, tangent of theta is 0 over -2, which is 0. So theta would be pi. Easy way to do that is if it's on the axis, we know that this is pi over here anyway. So our polar coordinate is 2 pi. Okay, next we are going to talk about polar equations, and a polar equation is an equation whose variables are r and theta. So we're going to convert these rectangular equations to polar equations by plugging in what we know. So remember, x is the same as r cosine of theta, and y is the same as r sine of theta. I'm going to go ahead and factor out an r. So I have cosine of theta plus sine of theta, and I'm going to solve for r by dividing. So if I divide by cosine of theta over sine of theta, my equation is 5 divided by cosine of theta plus sine of theta. Okay, next one, we're going to do the same thing. We have our cosine, that was a really bad cosine there, our cosine of theta minus 1 squared plus our sine of theta squared equals 1. And this one's going to require some algebra. So if I multiply all this out, we get r squared cosine squared of theta minus 2 r cosine of theta plus 1. And then we get r squared sine squared of theta. And we're going to simplify this. We're going to move some stuff around and regroup it. Okay, so I'm going to bring my r squareds here. So I have r squared cosine squared plus r squared sine squared minus 2r cosine of theta plus 1. And actually, I'm going to move that plus 1 over, so I have an equal 0 there. And then when I do this, I have r squared times cosine squared plus sine squared, which you should remember is the same as 1. Okay, so I really have r squared minus 2r cosine of theta. And we are actually going to factor this. We have an r in common, so I have r times r minus 2 cosine of theta equals 0. So if I set that up into two parts, I have r equals 0 and r equals 2 cosine of theta. Well, if r is 0, that's taken care of in this pole, so this fits in there, so we don't really need to worry about it. This is our equation. And then we're going to switch from polar back to rectangular. Okay, using those same things. So if I know my radius, I can plug it in there. So x squared plus y squared equals 25. Okay. For this one, I'm going to take tangent of both sides. So I have tangent of theta, and at pi over 4, tangent is 1. Okay. So if I know tangent of theta is 1, that means y over x is 1, and I can solve to get y equals x. Okay, so when I'm doing this, I'm using this for the first one, and I'm actually using this for the second one. Now we're going to go back and use this for the third one. Okay, so if I know r is 3 cosecant, I can rewrite that as 3 over sine of theta. Now, if I multiply by sine of theta on both sides, I get r sine of theta equals 3. R sine of theta is the same thing as y. Okay, same idea here. I'm actually going to multiply. I want to get r cosine so I can substitute. So I'm going to do r squared equals -6 r cosine of theta. This here is the same as x. So r squared equals -6x. I know that r squared is equal to x squared plus y squared. So I'm going to plug that in. And I need to do a little work, like we did in conic sections, to put this in form of a circle. So I have x squared plus 6x plus, I'm going to fill in the blank, plus y squared equals 0 plus fill in the blank. So half of 6 is 3, 3 squared is 9. So if I factor this, I get x plus 3 quantity squared plus y squared equals 9. And that is our equation. Okay. As far as this goes, as long as you're okay with manipulating these, not so concerned if you memorize the formulas right now. We will use these in BC Calculus when we get to that point in second semester. So like I said, I just want you to be familiar with these. If you have any questions, let us know. There is practice in your packet or on this page, as well as some extra practice in some of the other websites that we've included. Have a great day.